is on clean water for sustainable development and use of solar pumps. Chairman has articulated the need of the solar pumps for water sustainability. You know, when we talk about solar pumps, we are essentially talking about solar photovoltaic water pumping systems. In our country, we have been using the solar photovoltaic water pumping system from early 1970s, when the photovoltaic module was really very expensive. But still, we are using it for a purpose. These were being used for irrigation and drinking water supply in remote, unelectrified areas where even reaching diesel was not a very simple proposition. It really worked very well, and the need was so paramount that government put up a lot of funds for developing solar thermal pumps with the hope of finding a cheaper alternative. A few pumps were developed by our different research and academic organizations. I remember when I joined the Ministry of New and Renewable Energy in 83-84, there were parliament questions on solar pumps for irrigation and drinking water. And I remember that time 2 solar thermal pumps were being used as demonstration units. But somehow, as the photovoltaic module cost has started coming down, the solar thermal pumps could not find the light of the day in the commercial solar water pumping market. So as the photovoltaic module cost has gradually come down, the program for solar photovoltaic-based water pumping system was enlarging. I remember a study by GIZ in 2013. They found that with the then prevailing cost of solar photovoltaic modules, the cost of a diesel-powered water pumping system was 40% more than solar photovoltaic water pumping system. I'm talking about the life cycle cost. So solar water pumping system based on photovoltaic modules were getting economically attractive, I think from 2007-8 onwards, as the photovoltaic module cost has come down and the diesel cost started going up. Even in this period, if you compare it with grid electricity powered water pumping system, solar photovoltaic water pumping systems become economically attractive if you really consider the real cost of electricity, not the subsidized cost or not the cost which does not take into account the environmental problem. In our country, we have around 30 million ground water pumping systems for irrigation purpose. 70% of these pumps are being powered by grid electricity and 30% by diesel. Even after prolonged schemes of Ministry of New and Renewable Energy and many other state governments, the solar-based pumps could not get a share of more than 0.5% in this total matrix. The pumps, which are powered by grid electricity and diesel, have to pass through many other problems. Problems are because many of these pumps are being used in the agricultural field, where it is essentially tail end of the grid. So the voltage drop of the tail end of the grid, the power cuts, and even non-availability of diesel affected their operation, and therefore the agricultural production for which these pumps are being used automatically get affected. Because the very purpose for introducing these pumps for irrigation is that these are needed for agriculture. We have to depend on rainwater, which, as we have seen, and things are happening more and more with climate change, that we cannot totally depend on the natural rains. Now, this electricity or diesel for this 30 million pumps, the fuel for operating these pumps are highly subsidized. This has been done for quite a long time. Again, this was being done for that very specific purpose of boosting agricultural production and helping the farmers for putting their efforts into agriculture. They have certainly, this subsidized cost of electricity and diesel have certainly helped in increasing agriculture production, in making the growth rate higher. But it is also true that this subsidized energy cost has put the total sector in a very inefficiency as far as energy is concerned. A study, I think, undertaken in 13-14 or 14-15 showed that while the electricity consumption in the agricultural sector is 22%, the revenue of the discoms were only 8% from this source. That shows that discoms were stressed for providing subsidized electricity for the agricultural pump sets. And we had seen the subsidized diesel situation. As the solar water pumping system becomes economically more attractive, government is trying to put up these systems as an alternative to the electricity-based or diesel-based irrigation pumps. Ministry of New and Renewable Energy has come up with a new scheme you must be knowing about, that is Kusum Scheme. It provides a farmer with a solar water pumping system based on solar photovoltaic modules with a financing of 30-30-30-10 mode. That means 30% is the subsidy provided by the Ministry of New and Renewable Energy, 30% subsidy being provided by the state governments, 30% to be obtained as soft loan from banks and financial organizations, and 10% to be invested by the farmer. And also, under the Kusum scheme, these pumps can be connected to the grid with very specific purpose. Number one, that when you are getting solar electricity during daytime, you pump water. If your water pumping is sufficient for the irrigation, then you give the electricity to the grid and you get money for it. You get, government will guarantee giving you the price of the electricity at a feed-in tariff. Normally it is 3 rupees 50 paisa in many places where it is equal to the average power purchase cost of the DISCOM. And also some state governments have introduced a investment-based incentive because the farmer is to give back that 30% loan to the bank with a very soft loan, but he will have to give it back. For 7 years, the state governments are giving another incentive of around rupees 3 or 3 rupees 50 paisa. Now, if these schemes continue, then it has many benefits. Number one, the farmer will get irrigation water when the sun shines. So even if there is no electricity in the grid, or there is problem, a voltage drop in the tail end of the grid, water supply for irrigation is ensured. Number two, the farmers have the opportunity of selling this electricity to the grid when they don't need the water. Water is certainly not required throughout the year. So if they have the freedom, they can sell this electricity to the grid with a payment of the feed-in tariff and also the investment-based tariff from the DISCOM. Number three, as the farmers can sell this electricity, can earn something, they will not waste this electricity for unnecessary pumping. That would help water conservation and it would guarantee a kind of proper water management. The country will also be benefited. They are also not to find out land in this land-scarce country to put up solar power plants to achieve its target, because every farmer will provide 5 kilowatt to 10 kilowatt PV modules in a raised platform in their own field, for which government will not have to find out a new land. So if thousands and thousands of such pumps are introduced, multiplied by 5 kilowatt to 10 kilowatt, the government's target for solar would also be facilitated. But then, we are solar enthusiasts, we support this plan, but there are many people, they're critics of this scheme. They say it is too much a complicated scheme, and in order to solve the problems of inefficiency in energy or inefficiency in water management, you introduced universal metering. I think the question of universal metering, I argue with those friends who proposed this thing, that the issue of universal metering has been discussed, debated, and many state governments have implemented it after the turn of the century. But in many places, it has not been successful because of the political economy of the country. We have to remember the actual situation, the ground situation in the country, and we have to see the interest of thousands and thousands of farmers who are putting their efforts in agricultural fields. Anyway, what I want to flag in this session is another thing. I've just given the background. I told that solar photovoltaic water pumping systems. The technology has improved from 1970s to today substantially. It has improved in the sense that new technologies have been introduced, DC pump and AC pump. Proper electronics have been developed. The maximum power point tracking system have been introduced. Double axis tracking for the photovoltaic modules have been introduced so that you can get the maximum sun. Controllers have been developed which can control the pumping rate, sensing the level of the storage of water. And also the cost of photovoltaic modules have drastically come down. So solar photovoltaic-based water pumping systems are truly economically and technically viable today. One question, it is expensive. And I told the Kusum Scheme, which has been introduced by the Ministry of New and Renewable Energy, is trying to address that problem. The ministry has also brought out the specifications of these pumps, their testing criteria. Now, all these pumps, whether they are ground-mounted surface pumps or floating pumps or submersible pumps, are based on centrifugal pump technology. The DC pump is expensive but more efficient compared to its AC counterpart, which uses an AC induction motor. But anyway, the magnitude of efficiency of these pumps ranges between 25 to 35%, the overall efficiency. Some of the integrators claim around 40%, but that's all, that is the efficiency. In this context, I would like to flag the development of a second generation water pumping system. These are known as positive displacement pumps. Positive displacement pumps, though not being used for water pumping, are being used extensively in industry for high viscous fluid pumping and movement of this. In chemical industry, in many other industries, these are being used. Positive displacement pumps have one good point. The efficiency of these pumps are very high. The efficiency can go up to 70% compared to the centrifugal pumps, which can show maximum efficiency of 40%. Also, the positive displacement pumps have high part load efficiency. That means even if it doesn't work on full load, its efficiency curve remains on the higher side. So what happens when a positive displacement pump is introduced for water pumping? It starts operating as soon as the sun shines. With very small solar radiation, these pumps can start working, and as the part load efficiency is high, therefore the discharge rate is also high. So it works right from early in the morning to late in the afternoon. As a result, when the solar radiation curve is this shape, dump shape, it can give a square kind of efficiency curve, and the total efficiency and output of water from these pumps are very high. Also, these pumps can go much deeper. What Chairman was indicating, that deep aquifer, which we are not using by the normal centrifugal pumps, probably can be touched by these positive displacement pumps. Think of the sub-Saharan region where the water table is very low. There they can pump water with the help of these pumps. And we are not sub-Saharan region, but I do not know the changes which are taking place, how far we are from that situation. Right now, if you see our states on the Himalayas, Himachal Pradesh, you know Shimla has a perennial water supply problem. Also in many such places, because earlier they were depending on the natural streams. But now as the natural streams are not supplying the desired water because of population pressure, so many other things, they have to pump the water from underground. You need really deep, high power pump to pump water in these places. Also, many of these places, the solar radiation availability is lower than in many parts of the country because of clouds and winter days. Positive displacement pump will be a perfect choice for this. In our country, we have worked with positive displacement pump. I remember in 1980s, we had a project, Indo-German project with BHEL, where we tried this positive displacement pump with solar thermal power. We put up two systems, one in Pithoragarh in Himalaya region and another in our solar energy center, which has been rechristened as National Institute of Solar Energy. These pumps worked for some time, then it stopped. The reason what we could find out that it is sucking, it is very, very high power pump, sucking sand and stones, and it gets jammed, and therefore it cannot operate for longer time. We tried to solve the problems. BHEL took up a project, but somehow it could not give the desired result in late 1980s. Then I have not seen much efforts for development of these positive displacement pumps for water pumping in this country. But I believe that was 1980s late, and today is 30 years have gone, and it is an engineering problem. Certainly, solutions must have come up. Engineering problems can be solved if one tries sincerely. So this is just an issue I flagged, and for your consideration, that along with whatever centrifugal pump programs are going on, why should we not go for a better, efficient pump? I understand one thing, that if positive displacement pumps are being manufactured in very high numbers, its cost would be lower than the centrifugal pumps, and also its life is expected to be more. But then you need to have a lot of demonstration of these pumps, actual field study, and manufacturing of these pumps. But I think it is better to go for this phase if we can really get a pump which is 70% efficient compared to 35% efficient what we are using. After all, this session is for sustainable development. More the efficiency, more better we will be utilizing the resources. Thank you.